Hi, welcome to ARISTOTHINK. Today we're going to discuss about how many ways. How many ways to go from A to B in some different. You see, in here it's forbidden to cross this. Here you are obliged to go into this path. This you have to go through C and so on. Well, I know three ways of solving this kind of problems. The first one is the one that everybody knows. We just have to draw lines, right? Oh, the rule is you should always go right and down, never return or going up. Meaning, I cannot go like this, go up, I can always go down and to the right. So I cannot do this, that, return, no, down, yes. You see? So always right, always down. Well, of course, when you just draw lines, if I had I'm not going to draw it because I'm not going to solve like this. Everybody knows how to solve like this. This is one way. Make another line, another one, and at the end, there are so many lines. We have no idea how many paths we trace it, so it's pointless. If we're going to do like for 1, 2, 3, 4, 5 at most, it works, but some exercises have like more than 1,000 lines. We can draw 1,000 lines in here. So in here, I'm going to show the Pascal triangle and then the permutation. Well, what is the Pascal triangle? Well, the Pascal triangle, it is this one. Let's just remind you, it's a triangle with ones on the side. Let's build up. We just have to build a triangle. 1, 1, 1. The sides are always 1, always. Now, sides 1 and 1. What about in the middle? You add those two. It makes a 2, doesn't it? Now you are going to add those 3. Of course, the sides are always 1. Remember. Now add 1 and 3 makes a 4. 3 and 3 makes a 6. 3 and 1 makes a 4. And the sides are always 1. Remember? Always 1. If I would go into the 5th row, it would be 1, 5, 10. Come on, your turn. Yes, 10, 5, 1. Perfect. This is the Pascal triangle. You see, there is a symmetry, and the Pascal triangle is like a magical triangle. The Pascal triangle, at least how it's known on the Western world, is after Blaise Pascal from the 17th century. But of course, Blaise Pascal did not invented this triangle. This triangle was created. It started to appear around 300 years before Christ. Remember, Pascal is from the 17th century, 1600 and something. Like almost 2,000 years before Pascal, this triangle was created. But of course, it was not analyzed as deep as Pascal did. That is why Blaise Pascal was very important, because he took every knowledge that was around this triangle and analyzed everything and made a huge fuss, a huge development to connect everything. So he used everything he got to understand all properties that this magical triangle can give to us. If you are interested about the Pascal triangle, please follow the link below, or some card flying somewhere. Sometimes they're flying, the cards. And I have another video, I created another video explaining only about the Pascal triangle. So there are all the properties we can get from it, at least some 9 or 10 properties I'm going to show you. It's a beautiful tool, it's a beautiful calculator, I would say. Now, let's return to the Pascal triangle as it's known on the Western world. Of course, in India is called as the staircase of Mount Meru. In China is called Yanghui, and in Iran is called the Kayun triangle. You see why so many different names for the same triangle? Easy. It's because for each country, some mathematicians, they pass it throughout the time and they develop a little bit further. Blaise Pascal was the last one. So I'm going to call the Pascal triangle, if you excuse me. Now, how can you solve here? Well, Can you see the Pascal triangle? 1, 1, 1, 1, 2, 1, 3, 3, 1. So I'm going to put this triangle in here, but the triangle, I'm copy, paste, rotate. You see? So the sides are going to be here. All ones. I'm going to explain why once. First, because it is the Pascal triangle. But of course, why once? It must have some meaning. Yes. How many ways to go to this point? Assuming only rights and only downs. Only one way. There is only one way to get to this knot. How many ways to go into this knot in here? Only one possible, only one possible way as well. How many ways to go into this point? Only one. I says now, but I can't go like this. No, I can't, because this is allowed, this is forbidden. We can never return. So only one. This number, this coefficient, is going to be the number of paths possible to get to that point. You see? Okay. Now remember, 1 plus 1 is 2. 1 and 1 is 2. You see? 2 and 1. Remember? I'm going to add those 2. And it's a 3. You see? Now 3 and 1 makes a 4. 4 and 1 makes a 5. I'm doing the Pascal triangle. Like just like this. 1 and 1 and 2, 1 and 2, 3, like 3 and 1 is 4, and so on. 3 and 1 is 4, 3 is a 4, and so on. Now, we are going to see, we are going to visualize in a short moment the Pascal in here. It's coming, look. This is what? This is the vertex of the triangle. 1 is 1. 1, 1 is this 1, 1. Now, 1, 2, 1. 1, 2, 1. The third, 1, 3, 3, 1. 1. 1 and 2 makes a 3, agree? 1 and 2 makes a 3. Again, I'm adding those numbers. You see? I'm adding those numbers, and the result is this. You see? 1, 3, 3, 1. 1, 2, 1. Can you see there? Now, 1 and 3 makes a 4. 3 and 3 makes a 6. This is a 10. You can do with me. You don't have to say everything. 20. Now, 20 and 15 makes a 35. So, there are 35 different ways. Now, in here, I'm going to do the same, but there is something different. I'm going to force you to go in here. Yeah, okay. So, you have to go through point C. Well, 1, 1, 1, 1. Now let me ask you. I'm telling you, I'm going to disregard this area and disregard this area. So that is pointless. We cannot go in here. And I want to ask you, why is that the same in here? I cannot go on those shaded areas. Why not? Because if I go into this place, I can never return to C. If I'm allowed to go to this place, here, it means I can go straight in here. And then I have to go down. To go to C, I would have to go back. I cannot. So all those to the front and all those lower than C, I cannot use, because let's suppose I'm allowed to go into this point. Yeah, I could. This would be 1. Right? I won't write because I cannot go in here, but let's suppose I could. Then to go to C, I would have to go in here, up, or in here and up. I cannot go up, I told you. Okay, so those areas are not going to be used. 1 and 1, 2, 2 and 1, 3, 1 and 2, 3, 3 and 3, 6. Okay, now I have 6 different ways to go from A to C. And now I have to go from C to B. Now let me ask you something. If there are 6 ways to go to this point, there is nothing different. I have to go with 6 options, and so 6 in here. Do you agree with me that those 2 must be 6? It can't be 7, because look, 6 ways to go up to here. To go to this point, I have to go straight in here. There is no other option. And to go to this point, it's straight to here. I cannot go down, because if I go down I have to go up, and it's not going to work. You see, if I have to go down, I have to go up again. So 6, 6, and here the same 6. So can you see now that where we had once on our Pascal triangle, now we have the sides with 6? Of course, the laterals of the triangle are always the same as the origin. So 6 and 6, 12, and this is 18. So 18 different ways. Okay, no problems. Now, in here we have a different rule. The rule is, in here I had to go through C. I had to. That is why I had to, those became all 6s. Because of that knot, I had to go there. Now, I'm going to choose this knot, but this means I cannot go here. So, I can go here. Yes, of course I can. I can go anywhere I want to. I just cannot go in here. I can choose this path if I want to. I can choose this path if I want to. No problems. So let's do our Pascal. 1 and 1, 2, 2 and 1, 3, 3 and 1, 4, 4 and 1, 5. Okay, 5. Now, 1 and 2, I have to put some number here. What do you think it is? Come on, think for a moment. I wait. It's important. Should I put 3? I'm going to give you some options. It's going to be either 3, 1, or 0. Choose. Not choose, think. 3. Is it 3? I just have to add. Is it 1? Just 1? Or is it 0? You can pause the video. Think it is important. That number we're going to choose means how many ways can you get to this point. Just recapitulating. Why did they say 3 in here? Because there are 3 ways to go to this point. Look. 1, 2, and 3. Why 4 ways to go to this point? Because there are 4 ways. 1, 2, 3, and 4. So remember, this coefficient is how many different ways we can get to that point, to this knot. You see? And about here. What should be the number I should write for this knot in here? On the cross. The number I cannot cross. Maybe it's a poison, maybe it's a spider, maybe there is a predator, maybe there is a war. I cannot go into this region. What is the number? Yes, of course. 0. If you said 0, you are correct. Why? I said it's forbidden to go there. There are 0 ways I can go there. You cannot even consider going there. And now, so when I say 1 and 2 is 3, no, there are 3 ways. They cannot go here. And about here, continue. 0 and 3 makes a 3. Of course, this is 0. This number is 0. Add that number with that, remember? We add those 2 numbers, always, and this is the answer. Remember? Now 3 and 4, 7. This is 12. 7 and 5, 12. 1 and 0, 1. Remember? 1 and 0, 1. 1 and 3, 4. 4 and 7, 11. 11 and 12, 23. Different ways. Now, last one. This is, the rule in here, it says this. I have to go from A to B, always right, always down, but I have to pass through here. So I have to collect something, or I have to go through here. That means that I'm going to have to disregard this area. See if you agree with me. This area and this area as well. Okay, now 1, 1, 1. 1 and 1 makes a 2. 2 and 1 makes a 3. So there are 3 ways I can go. Oh, no, it's wrong. Why is it wrong? No, no, no. I cannot choose this one. I have to dash this one as well. Why is it wrong? I cannot go into this knot. Why? Simple. If I go into this knot, it means to go into this path, which I'm obliged to, I will have to return. I can't return. So I can never go forwards a path I'm obliged to go, because if I go to this path in here, like the 3 that I just wrote, to go to this knot in here, I have to go, I have to pass through these streets. I will have to return. I cannot return. So only 2. So what about this one? The same, 2. Of course, once I have 2 options to go here, to go to the next stop, there is no more options, so I have to stay with the previous option, which is 2. The same here. 2 in here as well, agree? 2, 2, 2. Once I start with 2, there is a tunnel. I cannot go any other way. Always 2 options. Now, the same here. We had 6s, but now we're going to have 2s. Of course, this is closed as well. Of course, you cannot choose any one of those in here. And this is going to be a 2 as well. Why 2? Well, because this is 2, 2. How many ways you go to this spot? Well, 2, the tunnel. Then there is the only way I can go to this spot if I just go straight. If I go down, I would have eventually to go up. I can't go up. So 2, 2, 2. So 2, 2 makes a 4. This one is 4. And this is a 6. So in here there are 6 different ways. Okay, no problems. Now the last one is going to be a little bit different for you. For this one we're going to discuss about permutations. If you don't know about it, well, it's not the objective of this video to explain permutations, but if you do, follow me. If you are not, I'm sorry, but if I go explaining this, man, the video is going to be like 30-35 minutes. Now, we're going to use permutations here. Now, how many ways are there to go from A to B? 1, 2, 3, 4, 5, 6, 7, 8 horizontals. Continuing. 9, 10, 11, 12, 13. This is a 13. So there are 13 paths which I can choose to go from A to B. So 13 factorial. Of course, I have 13. Imagine those are horizontal arrows and down, vertical down arrows. I can switch between 13 arrows, one here, one there, one here, one there, one here, and there. So I have 13 factorial to choose between. Now, there's something. All those 8 horizontals, they are the same. It doesn't matter. So I have to remove this repetition. Now, down, I have 5 equal verticals. 5 factorial. Well, we can do this. It's going to be like 13 times 12 times 11 times 10 times 9 divided by 5 times 4 times 3, 2, so 2 times 10 cancels. 3 times 12, so this is going to be about 13 times 11 times 9. So this is about, come on, 13, 10 times 10 is 100. So about 13 hundreds. Okay, about. Now, about, can you imagine do this with lines? Impossible. So in this case, can you imagine also to draw the Pascal triangle there? The Pascal triangle works with numbers like 20, 30, 40, 50. Man, there it's impossible. Don't waste your time there. So when you have a bigger grid, you better use permutations. Now in here, the only difference is that we have to go through C. So I'm going to use this. You see? I'm going to use this path. You see? This path. And also this path as well. I have 2. Can you see that we have 2 areas that we have to work through? Now, what's going to be? We have 2 problems. Let's suppose those are 10 ways. Much more, but let's suppose 10 ways. and those are 5 ways. So I have 10 ways to go from A to C, and then I have 5 more from C to B. So what should I do? What should I do with this 10 and this 5? Should I add or should I multiply? Think. 10 ways. Imagine, suppose 10 ways in here and 5 ways in here. Should I do it 10 plus 5 or 10 times 5? Of course, multiplication, of course. Because for every one of those 10, I have another 5. So 10 times 5. Now, just do this. How many ways to go from C? 1, 2, 3, 4, 5, 6, 7, 8 ways. So it's going to be 8 factorial. The repetitions, 5 repetitions horizontal and 3 repetitions vertically. Multiply by. I have like, again, 1, 2, 3, 4, 5. I have 5 different paths to choose from, but between those 5, 3 are horizontal repetition. I have to remove, they are all the same, and 2. Now what's going to be that? Cancel with this. So what we have 8 times 7 times 6 times 5 times 4 times 6 times 2 times 6 in here. 3 is 3 times 2. So I have 1 6 in here. I have another 6 in here. And I have 2. So this 6 cancels with 6. What's this? 6 times 6 now. Then I can cancel with 2 with 8, which is 4. So 4 times 7 I have 28 times what? 28 times 20. Yes. Okay, so 4 times 20. You don't have to forget anything. So okay, so 2 times 28 is 56. If I'm not mistaken. This number, it is smaller than this. Of course it is. Why? It's small. Well, because I have to remove. I have to remove that. So I have less option. So that is what I wanted to show you today. Thank you enormously for watching this with me. I had a great time doing this video. It's something I wanted to do for a long time. And that is my channel. My channel is a place to teach students in school, but also to not teach, but in this case it's going to be to enhance or to feed some other brains that already passed through that some years ago, but you are just trying to find something new to feed your brain. And this is the other objective of my channel. Thank you enormous for being here. Please, if you enjoy this video, if you stay so far, consider subscribing, giving the like. It is the only way my channel can survive at YouTube. So I really need your like and your subscription if you think it's worth it. Thank you very much. It was a pleasure to show you this, and see you next time. Bye bye and have a wonderful day. See you. Haha, puffed.